This is an example of the RSA algorithm. The RSA algorithm for encryption gets its strength from the fact that it is very easy to multiply two prime numbers together to get a big number, but it is very difficult to figure out which two prime factors that big number has. And we will go through an example without a whole lot of explanation of the math behind it, but there is certainly plenty of that. If you're interested, come talk to me and I will point you towards resources and explain. So to start with, we're going to just put two prime numbers in, P and Q. I just looked these up. We're going to use 3-digit primes to make our numbers a little bit more manageable in actual examples on using your computers. These numbers are 150, 160 digits long, very big. Okay, so 131 is prime and 167 is prime. We need to find the number n, which is we're actually going to share with the world, and that n is going to be the product of these two numbers, so p times q. Right? In order to make our math work, we also need to figure out the Euler number, and that is using the following equation. It's p minus 1 times q minus 1. So if I put that formula in here, get the Euler number of 21,580. Okay, now we need to pick a number e, which we will also share with the world, which is relatively prime to all of our numbers. Easiest thing to do is to actually pick a number that is prime, period. And so we're going to pick 761, which I also looked up in the table. And then we just need to find a number d. And this number d is going to be a number such that 761 times d is going to be equal to 1 if we run it mod this Euler number, which means that that number would be equal to something like 21,581 would be an example of number that was equal to 1 when multiplied by 761. Also, any multiple of 21,580 plus 1 would work as well. Now it turns out that there's actually a way to figure this out pretty quickly, and we use this algorithm in the following way. We set up A and we set up B, we set up a D and a K, and we are basically using some matrices here. We're going to start out with A equals 1, B equals 0, 0, and 1. And we're going to put in our numbers that we need here first. So we're going to start out with the Euler number, 21,580. And then after that, we're going to put in 761. Okay, and then for this K number, we need to find how many times 761 goes into 21 and 580. So we can put up our calculator and say 21,580 divided by 761 equals 28 and change. So I can put in a 28 here. Okay? And then down here I need to know what the remainder is after we do this. So I'll bring back my calculator. Okay, I can subtract 28, and I'll get rid of all the whole parts, and then if I multiply again by 761, I should get a whole number back. That's 272. So that's what my remainder is 272. Okay, so 761 goes into 21,580 times 28, remainder 272. Okay, then I'm going to do the same thing where I'm going to look at 272 into 761 and figure out how many times that goes in. So 761 divided by 272 equals 2 and change, so that goes in twice. If I want to figure out how much left over I have, I can subtract 2 and multiply by 272. That gives me 217. Okay, 217 is going to go once into 272.1, and then the remainder is just going to be what's left over here, and it looks like, well, we'll just do this, minus that, 55. 55 goes into 217, let's see, not quite 4 times, so 3 times. Okay, if we look at, so 217 divided by 55, it's 3 times, minus 3 times 55 equals 52. So we've got 52 left here. 52 goes into 55 once, of course, and then there's a remainder of 3. 3 goes into 52 a whole bunch of times. So 52 divided by 3, 17. 17. There's 1 left over, and 1 goes into 3 times, and there is 0 left over. And that's the end of that grid. We then need to fill in some more numbers. So we're going to just put a background on here, so we know that we're in the Euler grid area. Okay. So then to figure out these other boxes, we need to do something a little funky. We need to take, let's do this box here. This would be A123. This box right here is going to be equal to this number minus this number times this number. Okay, so in that case we're going to do 1 minus 0 times 28, which of course will be 1 minus 0, which is just 1. For this number, we're going to do 0 minus 1 times 28, which is going to be negative 28. We do the same algorithm here. We do 0 minus 1 times 2, which is negative 2. And here we go, 1 minus negative 28 times 2. So 28 times 2 is 56, so that's 57. 1 minus negative 56 is 57. All right. 1 minus negative 2 is 3. And so on. Now it turns out that we're just doing the same thing over and over again. So we can actually put this into an equation. So this is going to be equal to this number minus this number times that number. Notice we still get 1. The beauty is I can actually drag this down to here. And this I can do the same thing. It's equal to this number minus this number times that number. And now notice I still get negative 28. I can drag that down to here. Now it turns out that this number right here, once we get down to 1, is D. And you'll have to look up the Euler algorithm to really understand why, but I'll be happy to explain it to anyone, or the whole class if everyone would like to understand how that works. Okay, so now we've got our 2 keys. Now 761, this is our private key. We don't share this. Okay, this is our public key. We do share. And this is our public key. We do share. Okay, so this is public. We'll make that green. That's green. This is everything else we hold private. Okay, so we'll make that something sort of red. Okay, so everything else, and then these other ones we're just using calculations. Okay, so we don't actually need these at all. We'll make those pale. Okay. So this is our private key and our public key. Okay, so this is how it works. So say we have a message, and right now we're limited to messages that are less than n here. So if we're writing something in text, we'd have to convert it into some sort of numeric form and send that, because this is all, of course, math. So let's say I want to encode the following message. And it is 1, 2, 3, 4. Okay. What I now need to do is I need to take this message 1, 2, 3, 4, and I need to raise it to the 761st power. And I need to do it modulo this number here, this n number, which is like adding around a clock. So for example, with a clock, we do this all the time. So if I take 11 and I add 4 to it, right? On a clock, we all know that that is 3 o'clock. Okay, so what we've done is we've just done 4 plus 3 mod 12. So this is equal to 11 plus 4 mod 12 is 3. Okay, Excel will actually allow us to do this. There's a function called mod, so I can do 11 plus 4, and I can say that my modulo divisor is 12, and I'll also get 3. So there's a way to do it inside of Excel, which is really handy. In fact, it'll come in handy real soon. Okay. Okay, so here we are. We need to now take this number and we need to raise it to the 761st power.